In this concept, we're going to talk about angles of elevation and depression. Now, an angle of depression is the angle between a horizontal line and the line of sight from the observer to an object at a lower level. Okay, so the object is at a lower level while the observer is looking from a higher vantage point, as shown below. So, in this case, in the case of an angle of depression, which is this, the plane is the observer and the object is the person standing on the ground. So the plane, or the person in the plane, the pilot for example, is looking down towards the person standing on the ground. Okay, so the object is at a lower level. So this is the angle of depression between the line of sight straight forward of the plane and the line of sight towards the person or the object. The angle of elevation is the angle between a horizontal line, right, and the line of sight from the observer to an object at a higher level. So in the case of an angle of elevation, the object is higher and the observer is lower, is looking from a low vantage point. Okay, so in the case of an angle of elevation, this one, the person is the person is the observer, and the object is the airplane further up. Okay, and this is the line of sight from the person to the airplane. So in this case, this is the angle of elevation. So angle of elevation, angle of depression. Let's look at some examples. So first example is the example of a boat and a lighthouse. So the angle of elevation is the angle at which the sailor on the boat or in the boat observes the top of the lighthouse. So this is the angle of elevation, right? Between sea level and the top of the lighthouse. The angle of depression is the angle at which someone on top of the lighthouse, okay, is observing the boat. Okay, this is the angle of depression between the horizontal of the person on top of the lighthouse and the line of sight between that person and the object on the ground level or at sea level, which in this case is the boat. Okay, let's look at another example. When landing, a jet will average a 5-degree angle of descent. So angle of descent is essentially the same as angle of depression. Okay. So an airplane will average 5-degree angle of descent. What is the altitude x to the nearest foot of a jet on final descent as it passes over an airport beacon 8 miles from the start of the runway? Okay, too many details, but again, it does not have to be intimidating. Just break it down piece by piece and start plugging in the numbers. The best thing to do is, if you did not have a picture, draw a picture. Okay, draw a picture. Okay, very important. Always make sure you have a picture to make things easier, whenever warranted, of course. So a jet on final descent passes over an airport beacon. So the airport beacon, or an airport beacon, is placed 8 miles from the start of the runway. So if this is the start of the runway, meaning by the time the airplane reaches here, the elevation at this point, right, will be 0. So we can treat this as a triangle. This is one leg, right? And then the horizontal is one leg. And this is where the airplane is at right now. And now it passes over an airport beacon, which is not as high as the airplane is flying, but it happens to give us this leg, right? So the airport beacon, let's make it look like a lighthouse, right? Some beacon. It looks like it's underground, but it's not really underground. It's overground here, right? So beacon, light. Okay. So it gives us this distance. from the position of the beacon to the start of the runway. Okay? And this distance is 8 miles. So essentially we have a right triangle, right? This is 90 degrees because this is where the airplane is right now. Since the angle of descent is 5, then this angle is 85. Okay, 85 degrees. So again, because this is a right angle, so these two are complements to each other. So this angle is 85 degrees. And then we need, what is the altitude x to the nearest foot? So this is the altitude, right, which is this height of the airplane as it passes over the beacon, right? So we essentially we have a right triangle, right? It's horrible looking right triangle. So we have 8 miles, we have 85 degrees, this is 90 degrees as we know, and then we need x. So we have the angle, right, 85 degrees, and then we have the adjacent side and we have the opposite side. We do not have the hypotenuse, in which case we would want to use the tangent property, okay, because we have the adjacent and the opposite sides, or legs. So tangent of 85 is opposite, which is 8 miles, over adjacent, which is x. And again, from there on, we just need to solve for x, and we get x is equal to 8 over tangent 85, which is 0.7 miles. Okay, but keep in mind, it is asking us what is the altitude x to the nearest foot. Okay, so here we got miles because we've plugged in 8 miles. We need to convert that to feet. So we multiply by however many feet there is per mile, which is 5,280, and we end up with an altitude of 3,696 feet. Okay? Another example. A sailor observes a lighthouse at an angle of elevation of 15 degrees. The lighthouse is 100 feet high. How far is the boat from the shore? So this is the lighthouse, right, 100 feet high. Angle of elevation, this is the sailor. Angle of elevation is 15 degrees to the top of the lighthouse. So the sailor measures 15 degrees using some measurement device that measures elevation or angle of elevation, right, on the horizon. And the lighthouse is known to be 100 feet, okay? Now, at the moment the sailor measures 15 degrees, what happens to be the distance of the boat from the shore, right? Because obviously as the boat approaches or moves away from the shore, this angle will change. The height of the lighthouse will always be 100 feet, but this angle will change depending on the distance from the shore, which is x, which is unknown in our case. Okay. Find the value of x, the distance the boat is from the shore. So we have the adjacent side, right, and we have the opposite side. We do not have the hypotenuse, so it is very befitting to use the tangent property again. Tangent 15 is opposite over adjacent, which is 100 feet over x. And from there on, again, isolate the x. So we get x equals 100 feet divided by tangent 15, which, when simplified and calculated, gives us x is approximately 373 feet. So the boat is about 373 feet from shore. Okay, and here we have our exercises. Please pause the video, work on these, and come back for the solutions. All right, a plane is approaching the runway of an airport. The pilot observes the runway at an angle of depression of 5 degrees. If the plane is 5,000 feet above ground, how far is the runway from the plane? So draw a picture. Plane, let's make it simple because drawing on a screen is difficult. Alright, horrible looking plane, but you get the idea. So the plane is here, and the angle of depression is 5 degrees. So always be careful with this, okay? If your angle of depression is 5 degrees, then the angle inside the triangle will be the complement of 5 degrees, which is 85 degrees. Okay? And the plane is 5,000 feet above ground. So this distance is 5,000 feet. Okay? How far is the runway from the plane? So if this is the start of the runway, and this is where the plane is now, what is this distance? Let's call it x. So we have an angle inside the triangle, 85 degrees, that's known. Of course, this is 90 degrees, but, we don't work with it at this point. We just work with the other angles. So 85 degrees. And then we have the adjacent leg, 5,000 feet. And we have the opposite leg. So this is the opposite leg, which is x, and this is the adjacent leg, which is 5,000 feet. Okay, so again, we can write the tangent property. This is the most befitting. So tangent 85 is opposite, which is x, over adjacent, which is 5,000 feet. Okay. So multiplying both sides by 5,000, we get x equals 5,000 tangent of 85, which, when evaluated, will give us 57,150 feet. Okay, which can be converted to miles by dividing, so 1 mile per, 1 mile per 5280 feet. Okay, so it takes 5280 feet. Actually, I'm sorry, this is times. 5280 feet per 1 mile, right? So feet cancels with feet. So essentially, we divide 57,150 by 5280, which gives us about 10.8 miles. So this is 0.8 miles. We could have very well left it in feet, but again, it's nicer in miles because, it's easier to fathom 10.8 miles than it is to imagine 57,000 feet. Yeah? It's more familiar. Next exercise. A man is observing a bird at an angle of elevation of 65 degrees. So, again, draw a picture. That picture. Okay. So, man, bird. Okay, just make believe this is a bird. Okay, beak and everything. Angle of elevation, 65 degrees. If the bird is flying 60 feet above ground, so this is 60 feet, right? How far is the man from the bird? What is this distance? Let's call it x. So again, we have an angle, and we have the adjacent side, and we have the opposite side, or leg, which calls for using tangent again. So tangent of 65 degrees is equal to 60 over x. Okay, solving for x, we get, essentially we need to multiply both sides by x, and then divide by tangent 65 to isolate the x, which gives us x equals 60 over tangent 65, which evaluates to about 28 feet, rounded to the nearest foot. Okay, hopefully this was clear. This is it for this concept. See you in the next video.